This lesson is on trigonometry. The goal is to use sine, cosine, and tangent ratios to determine side lengths and angle measurements of right triangles. The standards are geometry, similarity, right triangles, trig number 8, geometry, modeling with geometry number 1, and geometry, similarity, right triangles, trig number 7. Now, I know a lot of you are thinking, oh, I can't do trigonometry is so scary, scary, scary. Trigonometry is nothing more than the study of the relationship between lengths of sides and angles of triangles. That's all that is. So, what I want you to understand by the end of this lesson is that if you know certain combinations of side lengths and angle measures of a right triangle, you can use certain ratios to find other side lengths or other angle measures. So, I know this lesson is called trigonometry, but from now on I'm just going to use the word trig in place of trigonometry. So where are you on the scale when it comes to trigonometry? Have you ever seen sine, cosine, tangent ratios? At the top of your notes, put a 1, 2, 3, or 4. Okay, here are your trig ratios. We're going to talk about right now this angle right here, angle A, and everything is going to hinge on this angle A on this particular triangle. So, if we were looking for the sine of angle A, we would use the leg, the opposite of angle A, over the length of the hypotenuse. Okay? Cosine of angle A is the length of the leg adjacent over the length of the hypotenuse. It makes a fraction, that's all it is. And if we wanted the tangent of that angle, we would use the length of the leg opposite over the length of the leg adjacent. Know it sounds tough, going to get simpler. Just wanted to show you what these ratios mean. So you find your angle, in this case angle A. You either look for your opposite, your adjacent, or your hypotenuse based on what they want you to find. Alright, so before you get stuck, before you get all worried about it, we're going to give a name to each side of a right triangle based on this angle that we're going to be looking for. So, if this was the angle A, they give this angle this little Greek symbol right there. That's just for that angle. We have, if we were looking for this angle here, this is the leg opposite it. Notice the leg doesn't touch the angle. That's opposite. The leg adjacent touches it, but also touches the right angle. And of course, hopefully you know that the hypotenuse is across from the right angle. It's the longest side of a right triangle. It also touches the angle that we're looking for, or that we're talking about. Not that we're looking for, it's the angle that we're talking about. Alright, so those are the three words we need to know. Those are the three legs we're talking about. The opposite, the adjacent, and the hypotenuse. Alright, here we go again. If we wanted the sine of that angle, we would make a fraction of the opposite leg on top, make a fraction and put the number of the hypotenuse on the bottom. Plain and simple. If we wanted the cosine of that angle, we would take the adjacent leg over the hypotenuse. Again, make a fraction. And if we wanted the tangent of that angle, we would take the adjacent leg over the opposite leg and make a fraction. Nothing hard, nothing difficult, nothing to lose sleep over. But how in the world do you remember which is which? Good question. Alright, you may have heard SOHCAHTOA. Okay? SOH. sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. TOA, tangent, opposite, adjacent. SOHCAHTOA, you can use that if you can remember it. You can use anything that has those letters. Sailors often have curly auburn hair till old age. I don't like that one. The one that I can remember is some old hen caught another hen, taking one away. I like also some old hag caught another old hag. Some old hag caught another hag taking one's aspirins, taking orange apple juice. Anything that can help you remember those will help you remember what your fraction, what your ratio looks like. Again, sine, opposite, hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Remember those, you got it licked. Okay, here's my first one. I want to find the tangent of angle T. That's my angle. The ratio says to find the angle or tangent of that angle is to take the opposite over the adjacent. SOHCAHTOA. There we go. So, my opposite is, remember, it's going to be across from it, but it's not the hypotenuse. So, the tangent equals 80. Sorry, it's 80 over the adjacent, which is 39. Now, that doesn't reduce. That is the tangent. The tangent of that angle T is 80 over 39. That's all it is. If you could reduce the fraction, then you can reduce it. Now it's your turn. Practice 1, find the tangent of angle M. Until you get real comfortable with this, I would write the ratio down just like I did. T equals O over A, just so you know you're using the right numbers. If you get a fraction, make sure you reduce it. This one says to find the sine of angle D. There's angle D. The ratio is the sine equals opposite over hypotenuse. SOHCAHTOA. So, the opposite is across from it. That's 8. The hypotenuse is the one across from the right angle. That's 10. And when I reduce it, I get 4/5. So the sine of angle D equals 4/5. Practice 2. Find the sine of angle V. Okay, this one is asking us to find the cosine of angle Z, and that's that angle right there. So, our ratio is the cosine equals the adjacent over the hypotenuse. SOHCAHTOA. So, the adjacent is the one right next to it. So that's going to be 32. And the hypotenuse is the one right across from, it's across from the right angle. That's 68. And when you reduce that, you get 8 over 17. So the cosine of angle Z is 8/17. And that's all it is, how you do figure cosine. So hopefully you're getting a little less stressed about trig right by now. Practice 3. Find the cosine of angle V. Just make sure you notice angle V is at the top. It is not the angle on the left. Alright, these you may have to start looking and using everything that we've learned in this unit so far about how to find missing legs or missing hypotenuses so we can figure out the ratio. So let's take a look at this one. It says to find the cosine of x. Okay, so the ratio is cosine equals adjacent over hypotenuse. Well, the adjacent one is this one, but I really don't need to worry because we are working with right triangles, and we are working with, in our class, with 45, 45, 90, 30, 60, 90. So this one is a, excuse me, a 45, 45, 90. I also know this because I just multiply legs times the square root of 2, and that's what I multiplied that by to get this. So when I have a 45, 45, 90, my legs are the same. So this leg is also 10 times the square root of 5. So now I'm ready to go. And if you notice at the bottom it says write your answer as a decimal rounded to the nearest hundredth. So you're not going to have a radical answer here. So my cosine of angle x is going to be my adjacent, which is 10 times the square root of 5, over my hypotenuse, which is 10 times the square root of 10. When you put that in your calculator as a fraction, you will get the decimal. You get a big decimal, but when you round it to the nearest hundredth, you get 0.71. So that is the cosine of angle x. You're going to be doing the next 3 on your own. Practice 4, find the tangent of E. Practice 5, find the cosine of angle A. And your final practice problem is find the tangent of angle W. Remember, you're going to have to find that missing leg. Use the Pythagorean theorem to find the missing leg. So square the hypotenuse minus the square of the leg, then find the square root of that answer, and then you're going to set up your ratio and divide. Come see me if you aren't sure how to do this. It's pretty easy. So where are you now that you're getting ready to start your lesson? Put that at the bottom of your notes. Put a 1, 2, 3, or 4. And that's it for this lesson. Bye.